Hello, today I will be showing you how to create a color replacement shader and the logic behind how the shader works so that you can create your own easy customizable objects in no time. Now who is this shader for? This is a really great shader for maybe if you have a bunch of cat characters and you use the same eye texture for all of them, but you would like to add some variations so that your cats aren't just creepy clones of each other. This shader allows for creating an infinite amount of variance without actually having to go into each texture and manually recolor it yourself. One texture and endless color possibilities? Look interesting? Then let's get started. Before we begin, there are a couple of big limitations of this method that I think you should know about before putting in the work to create this shader. The biggest limitation is that it only really works for very stylized textures. If your texture has realistic shading incorporated into it, or your texture has gradients, the results of the shader won't be great. Also relating to the above point, this shader doesn't work all that great with textures that have soft anti-aliased edges. So I highly recommend that you use the constant fall off when texture painting your character if you plan on using this shader. And finally, for best results, it is best to use saturated colors that are far apart from each other on a color wheel. For example, I will be using red, blue, green, yellow, cyan, and magenta. Having colors that are far apart on the color wheel enables a more accurate color isolation process. Since the color is replaced anyway, it is fine to use these pure unrealistic colors in the texture, although you may have to put up with some initial creepiness as you work. First, we are going to create a color isolation node that will allow us to isolate a certain color of the image. The part of the image with a specified color will turn white, and the rest of the image will turn black. To start, we need to compare the individual RGB channels of our image to the RGB of the color we want to isolate. Since we are comparing the channels individually, we need to separate the image's RGB channels by using a separate RGB node. Go ahead and add a separate RGB node and plug your image texture into it. Add an RGB node that will be used as the comparison color. Set it to one of the colors in your texture. Duplicate your separate RGB node and plug your RGB node into the separate RGB node. Now we are going to compare each RGB channel. We will do this through the Math Compare node. The Math Compare node works like this. If the first two value inputs are about equal to each other, output 1, otherwise output 0. Mathematically, the compare node can be written something like this. The epsilon value is the amount of error allowed when comparing the two values. Think of it as a selection tolerance. The bigger the epsilon or tolerance, the less picky the compare statement is. As you can see, with a fairly high tolerance, the select tool even regards that pink color down there as basically red. Epsilon is just a fancy word for tolerance. Also, since the compare statement uses the absolute value lines, it doesn't matter whether you put something in the first value input or the second value input. The output stays the same. If you are using Blender 2.79, you will notice that there is no Math Compare node. For Blender 2.79 users, I will show you how to make your own Math Compare node. If your Blender version has a Math Compare node, then you can skip to 5 minutes and 35 seconds in the video. Alright, let's create a compare node for Blender 2.79 that closely mimics the compare node in Blender 2.9. Add a Math Subtract node. Plug its output into a Math Absolute Value node. Then, plug that into a Math Less Than node. Finally, there is a marginal safe zone amount in Blender's compare node, so between the absolute value and less than node, add a subtract node and subtract a really small number, like 0.0001. Select this group of nodes and group them together by clicking Shift-A, Group, Make Group. In the node group, drag the transparency dot to the two value inputs of the first subtract node in order to create two node inputs. Then drag the transparency gray dot to the bottom value input of the less than node. Hit N to open a panel on the left and name the last value input to epsilon. Exit the node group by hitting Tab. Name the group Compare and hit the F next to its name in order to save the node group. Now, you have your very own Math Compare node. The rest of the tutorial is about the same for Blender 2.9 and Blender 2.79. You will be just using this custom Compare node group instead of the Math Compare node. Alright, add a Compare node, plug the R of the image texture and the R of the RGB color into the Compare node. If you look on my screen, you may notice that yellow and white are also being counted as my red test color. This is because in the RGB model, red, white, and yellow all have the same red value. Although I am currently only comparing to see if a color in my image matches the color red, it is actually all three RGB channels that make the color red unique. So, I will need to add a comparison for the greens and the blues to get my computer to not be so colorblind. Let's do that now. Duplicate the Compare node and plug the G of the image and the RGB node into the first two inputs. Then, duplicate the Compare node and compare the blues. Now, we have successfully compared the channels individually, but we needed a way to combine them together. We only want our color to be replaced if all three channels return a value of 1. Based on logic and the power of math skills, we can do this by multiplying all the Compare nodes together. If even a single Compare node results in 0, the color will not be a match, because 0 times anything is always 0. Go ahead and multiply all the compare statements together by using two math multiply nodes. After multiplying all the comparisons together, you should be getting a more accurate color isolation process that no longer regards white as red. You can see that when I move the test color around to the colors of my image, the texture on the object will isolate that color by turning it white, while the rest of the object is black. Isolating a specific color from an image is all fine, but what you are probably really here for is to be able to turn that specific part of an image into another color. So on to step 2, creating the color replacement node. Add a Mix RGB node and plug the last multiply node into the FAC of the Mix node. On the Mix node, color 1 changes the background and color 2 changes the isolated part. I actually want it to be the reverse. I want the top color to control the isolated part of the image and the bottom color to control the rest of the image. So between the last multiply node and the Mix RGB, add an invert node. If we want to compare multiple different image colors, we will need to reuse all these nodes again multiple times. That would get messy really quickly, so we will make a node group. Select everything from the two separate RGB nodes to the Mix RGB node, but do not select the image texture or the RGB node. Then create a group by clicking Shift-A, Group, Make Group. The node background should have turned a greenish color. Select the group input node and hit N key on your keyboard to open up a panel on the right. In the Node tab, rename one of the image dots to Isolate Color. We also need to create two more inputs to control the color of the replacement color in the background. To do that, drag this transparency gray dot on the group input node to the color 1 of the Mix RGB node to create a new input. Rename this new yellow dot to Replacement. Create another input dot for the color 2 of the Mix RGB node. Rename this new yellow dot to Background. Exit your node group by hitting Tab on the keyboard. Rename your node group to Replace Color, and hit the shield, or if you're using Blender 2.79, the F that appears next to the name of the node. This will permanently save your node. If you were to accidentally delete the node and not hit the shield icon, you will lose all your work, even if you saved your Blender file. Don't make that mistake. Hit the shield to protect your node groups. Make sure that your image texture is plugged into the image input of the node group and not the Isolate Color slot. If it isn't plugged into the correct slot, do so now. Delete the RGB node. You can control which color to replace directly through the Compare Color input of your node group. Yay! If you have followed the steps correctly of this tutorial, you have successfully gotten one color of your image to get replaced. To be able to replace multiple, simply duplicate the Replace Color node, plug in the image texture into the image slot, change the isolate color to a different color of your image, and choose the color you want it to get replaced with. Then plug the replace color node output into the background input of the other replace color node. You can keep repeating the same process in order to replace lots of colors. Go all out! Alright, you may be wondering how this works in replacing all the colors of the image. Let me explain. It looks at the image at a certain color, the white. It's not the color red, so replace it with background. It's not yellow, it's not green, it's not blue, it's not cyan, it's not pink, so replace it with the background, which is that minty color. It replaces that color and looks at the next pixel. It goes through the same process. For the blue, it's not red, replace it with background, not yellow, not green. Oh, it's blue, so I replace it with the replacement color, which is black in my case. For the green, the process is the same. Not red, not yellow, it's green, so I replace it with the replacement color, a dark green. The process will keep repeating for every color, until eventually, all of the colors in the image get replaced. Oh, but wait, what are these annoying artifacts that are appearing when my colors change? This is because we don't have a high enough tolerance for the color isolation process. Remember epsilon? Good. It would be more customizable to control tolerance from on the node group, so we will add a tolerance input to the node. Go back into your node group by clicking on it and hitting Tab. Drag the transparency gray dot to one of the epsilons. Rename this new dot to tolerance. Make the range of tolerance be between 0 and 1, and drag the dot of tolerance to the other two epsilons. And, for convenience, drag the tolerance dot to the node output. Exit your node group, and plug the tolerance output of the leftmost node to the tolerance input of the next node. Keep repeating this process until there are no empty tolerance slots except for the leftmost node. Now to change the tolerance of all the nodes, you can simply change the tolerance of the first node. Go ahead and increase the tolerance to a good value. I find it best to put tolerance as high as possible, but low enough that the computer is still able to distinguish between all of the different colors. Trying to customize the character through the Properties panel can be a bit tedious trying to expand all those little tabs. So, an optional final step would be to create a master node group. Alright, I'm going to show you an inefficient way to create the master node group. Don't do what I'm about to do. I will show a better way in a moment, so just watch for now. If I were to select all my replace color nodes and add them to a group, I would end up with a whole bunch of image inputs on my group input node, even though I really only need one image input. Cleaning up the inputs would be a big hassle, so here is a more efficient way to create the master group. We're going to use a type of node called the reroute node. To create the reroute node, hold the Shift key and hold right mouse button and drag across all the image lines coming from the image texture. Your image texture node should have a singular line coming out of it. Then at the dot, the line spiderweb out to all the replace color nodes. The dot is the reroute node. It doesn't really look like a node, but it is very powerful in organizing nodes and creating node groups more efficiently. Now that the reroute node is in place, you can efficiently create the node group by selecting all of the replace color nodes and the reroute node and creating a group. And there is only one singular image input dot. That reroute node is a total time saver. Time to give this master node complete control over all the other nodes by adding inputs. Inside the master node, drag on the transparency dot to one of the replacement inputs of a replace color node. Rename the new input to a more descriptive name. I am renaming mine to nose because that hot pink isolate color is the nose part of my texture. Keep creating inputs for the master node by dragging on the transparency dot and dragging to all the different replacement slots of the replace color node. Also keep giving descriptive names to each input. You can change the order of an input by clicking on it in the Node tab and hitting the up or down buttons. This can be helpful in organizing the different inputs. Once all the replacement slots are full, add one final image input to control that empty background slot. rename the input to Other. This input will be the color of anything that has not been accounted for. On mine, it controls the background, because I do not have any replace color nodes for detecting the white. On your node, it will most likely be the color of the unwanted artifacts, so you will probably not even end up getting to see this color. Then, create one final input to control the tolerance, and exit the node group by clicking on its input and hitting Tab. Give the master node a fitting name. I'm calling my master node Cat Facial Details, because it will control the facial details of the cat. And, of course, don't forget to hit the shield or F icon next to the name to permanently save the node. And now, your character can easily and intuitively be customized in the inspector. I hope you have enjoyed this tutorial and learned something new. Happy blendering!